Today, on how it's made. Levels. At this factory, they really do their level best. Hot dogs. We'll have the frank facts from the factory. Abrasive grain. A job that has to be up to scratch. And sandpaper. A process that's all about going against the grain. The level was invented in the 17th century to put the right slant on things. We use it to make things plumb and true. Without it, buildings would lean, floors would be crooked, and maps would have inaccurate elevation information. So the level really has helped us straighten out our world. It's a centuries-old concept, but it still measures up. Centering the bubble in the level helps ensure you've done an even job of things. They start with a length of laminated birch wood. An automated router carves several holes in it. 3 of the holes will enclose the vials with the bubbles. 2 others will serve as hand grips. Once they've carved out plenty of niches, they move on to the perimeter of the wood. They cut grooves along the length of the wood to install a brass binding. But first, they unwind the binding into a forming machine. Rollers flatten it to get rid of the curl from the coiling. Other rollers then crimp the brass. The process will allow the strip to fit into those grooves on the level's wooden casing. They load pieces of the brass binding into a machine that slides them into the grooves. This gives the wood some reinforcement along the edges. Over at another station, a machine melts and molds plastic to make vials. Each one is slightly curved inside, so the bubble will have a place to sit. The vials wind their way through a vibratory feeder. It takes them to a gripper that rotates each one so the open end faces up. It's time for a fill-up with yellow mineral spirits, leaving just enough room for a bubble to form. A robotic arm plugs the vial with a plastic cap. Then, this sonic welder applies high-frequency sound waves to melt the cap onto the vial. The vial is then transferred to an inspection station, where a tiny camera photographs the bubble and sends the picture to a computer for verification. For this production run, the bubble should be about 1.2 centimeters wide. If it's on the mark, the computer allows the vial to move on. A printer head then hot stamps the centering marks onto the vial. But this spirit vial isn't quite ready. The next step is to bake them for 24 hours. The heat exposes flaws and the defective vials are rejected. Then they shine a bright red light onto a vial to illuminate it as it slowly spins between rollers. A camera photographs the bubble and a computer scans the image to check for shifting. Too much shifting could compromise the level's accuracy. The vials that pass the test then go into a molding system. It injects melted plastic into crevices to make a cradle for each vial. Next, a technician glues the cradled vials in the openings in the wooden framework, 2 to a slot. This is precision work. Each vial has to sit perfectly level. She checks her progress as it's magnified onto a monitor. Some vials are installed vertically to gauge if the walls are plumb, while the horizontal ones let you know if the floor is level. They fit little acrylic-rimmed windows over the vials to protect them. They screw rubber caps onto both ends of the level and give it their trademark stamp. Now these levels are ready to fight crooked construction and keep the business straight. Hot dogs are sausages on a roll. German sausage makers likely came up with the idea. In fact, there are reports of German immigrants selling them from push carts in New York's Bowery as far back as the 1860s. A century and a half later, hot dogs are still big on the street. To make standard hot dogs, they use a mix of pork, beef, and chicken. The cuts they use are called trimmings, pieces of meat left over from cutting steaks or pork chops, and they're mainly muscle tissue. They grind the trimmings the same way butchers grind hamburger meat, by pushing the cuts through a metal plate pierced with holes. They add processed chicken trimmings to the ground meat, then mix in food starch, salt, and other flavorings. The starch thickens the mix, while the flavorings vary depending on where the hot dogs are to be sold, because people in different regions have different tastes. They spray water into the mix and blend everything together in a big rectangular vat. A dash of clear corn syrup adds a bit of sweetness. They mix in more water, which helps to disperse the ingredients and make the hot dogs juicier. Another machine then shreds the meat batter into a fine emulsion and vacuums out any air. They load rolls of cellulose tubing into the stuffing machine. It pumps the meat puree into a long casing, twisting it every 13 centimeters, the length of one hot dog. It takes just 35 seconds to make a chain of hot dogs that would span a soccer field twice. Then they link 3 of those hot dog chains for an even longer string and load several at a time onto another machine, which drapes the hot dogs onto moving racks. It's all carefully timed so that twist always lands on the bar. The racks shunt the hot dogs through a liquid smoke shower, then through an oven with several cooking zones. The liquid smoke seeps through the casing and adds flavor to the dogs as they bake. Hot out of the oven, they drench these franks in very cold and salty water to chill them in preparation for packaging. The hot dogs then file down to an unloading zone. Here, a machine pulls them off the bars onto a conveyor. The hot dogs slide off the conveyor into metal containers. If you've been wondering what those black stripes are on the casings, all is about to be revealed, or should we say, unpeeled. The stripe is a marker. When they strip off that casing, the absence of a black stripe means the hot dog is done and ready for packaging. Inside the peeler machine, a tiny knife slits each casing along the top. Then, steamy air blows the casings right off the dogs. This machine peels 700 hot dogs a minute. An inspector checks to make sure the casing has been completely removed and that there are no defects. Then it's into a device that looks like a plastic bicycle chain. The sprockets position the hot dogs for packaging. They manufacture an incredible 300,000 hot dogs an hour at this factory. That's close to 2.5 million per shift. So they really do churn them out like sausages here. Good thing. It means lunch shouldn't be a problem. It takes grit to make sandpaper, as in abrasive grains. People have been using abrasive minerals to sand and polish things for centuries. Today, these minerals undergo heavy processing to make the grade, or should we say grades, because the grit grades run from very fine to quite coarse. Whether you're working on metal or wood, the right grade of abrasive grit can help you polish off the job. They start with bauxite, a naturally occurring mineral that looks a lot like clay. Or they might use alumina, depending on the kind of abrasive that's being made. They mix it with other raw materials in an electric arc furnace. Here, 3 large electrodes use intense electrical current to heat the mix to over 2,000 degrees Celsius. That's hotter than a live volcano. In fact, it looks a lot like lava as the minerals melt and blend together. Standing well back and using a long ladle, a technician takes a sample for chemical analysis. If it confirms that the mix is right, they empty the molten minerals into a big steel pot. The searing liquid weighs several tons, so they use a crane to transport it to a cooling area. "24 hours later, the abrasive minerals have hardened, so they bring in the wrecking ball. It cracks open the hardened mix, which is still quite hot at the core. They drop the ball repeatedly to break up the hardened minerals. They transfer the lumps of abrasive material to a conveyor system. More crushers, these ones have metal plates, break them up into fist-sized chunks. A magnet picks up any excess iron. And then it's into the roll crusher. It rolls them between 2 iron cylinders to grind them to bits. They assemble some screens in decreasing mesh sizes to make a kind of shaking sieve. It sifts the mineral particles through the screen with largest mesh first, then down to the smaller ones to sort them by size. For some perspective, we place a quarter against the various mesh sizes. As you can see, only the finest particles of grit would pass through the tightest weave. The bits of grit bounce across the screens and fall into hoppers, a different one for each size. The coarsest grains will be used for rough sanding jobs. The smaller the grain, the finer the finish. The finest grits are microscopic in size. To find out how the coarse abrasives shape up, they funnel them into a cup. Then they weigh the grains. A higher weight means they're densely stacked and therefore blockish in shape with blunt edges. A lower weight means they're flat and sharp. They use a different test for the most minuscule grits. They suspend the particles in an electrolyte solution, then apply an electrical charge. This allows them to count and evaluate the grits. Now these abrasive grits are ready to be packaged and shipped out. Making them has been, well, quite a rough job. Coming up, we'll go to the sandpaper factory, where they'll get some backing. We'll have the nitty-gritty on that process next. To make sandpaper, you need a lot of grit. There are thousands of tiny abrasive grains on a single piece. The whole idea is to create friction. By rubbing it against wood or metal, you can remove defects and make things look good on the surface. It's ironic that something so abrasive can make things look so smooth and polished. Sandpaper often isn't made from paper at all, but fabric like polycotton. They unwind the cloth into a machine with a printing press. Rollers with rubber printers magnetically attached to them stamp product information onto the cloth. The cloth then travels underneath the printing press, where more rollers apply a heat-setting adhesive to the unprinted side. They measure the density of the coating using a computerized system. This confirms that it's been applied correctly. Then the cloth is pulled underground to the electrostatic pit. Here, the environment is kept hot and humid, perfect for applying abrasive grains to the cloth electrostatically. They pour the grains onto a conveyor belt in the pit. The conveyor moves the grains under the rolling cloth and between electrodes and ground plates. They create an electrical field that triggers a mini sandstorm. Once airborne, the abrasive grains stick to the adhesive-coated cloth and become embedded in it. This electrostatic system allows them to evenly distribute the grains across the cloth. The grain-coated cloth now rolls out of the pit and back up to the next level. A technician cuts a swatch of the sandpaper, then peels away layers and makes 3 different cutouts. One of the cloth alone, another of the cloth with the adhesive coating, and a third, the grain and adhesive-coated cloth. He weighs each cutout to confirm that the sandpaper has been formulated precisely to specification. He also examines the gritty surface under a microscope to confirm the grains are standing up evenly. This production run gets the go-ahead, so they move the sandpaper through a 91-meter-long oven. It has 3 different heating zones, each one hotter than the last. The buildup of temperature bakes the grains into the adhesive. The sandpaper is now rough enough, but not quite ready. In the next step, they roll a coat of resin over the gritty surface, binding the grains to the base. After they cure the resin to the surface, they store jumbo rolls of the sandpaper in the warehouse until they're ready to cut them down to size. They slice some rolls into big sheets. These will be made into commercial sanding belts, the kind used in heavy manufacturing. Another machine punches out sanding discs. And at this station, they unwind 4 rolls of sandpaper simultaneously into a machine. It carves them, 4 at a time, into small rectangles. These rectangles won't be used for sanding, but as grip tape for skateboards. Whether you're a skateboarder, a handyman, or both, sandpaper will give you an edge. The real trick is choosing the right grit or series of grits for the job at hand. Otherwise, you could find yourself in a bit of a bad scrape.